so this one, if this was a test and it didn't say how to graph it or how to solve it, you could do it any way you want. So actually what we're going to do right now is we're going to solve it by graphing, and we're going to check, and then we're going to try this same exact problem with the other two methods. So we're going to try this one problem with all three ways. Listo? Okay, so let's graph the first one. When I look at the first one, like, the thing that jumps out at me is I can find those intercepts really easy. Because you remember, like for the x-intercept, it's y is 0. So all you got to do is put 0 for y, and it's just 0, right? So x equals 1. And for the y-intercept, x is 0. And so all you got to do is put a 0 for x, y equals 1. So we have those 2 points, 1 for y and 1 for x. So all I got to do is conectar los puntos. Because that's how you find the x and y intercept. For the x-intercept, y is 0. Like always and forever.
For the what?
For the x-intercept, y equals 0. Always. So all you got to do is put a 0 for the y. Right? Remember now? Sure?
Yeah.
It's $10.
Alright,
Okay.
the one is straight somewhere.
Now the other one, I can't actually find the x and y intercepts to make a graph because they're both 0. If I put a 0 for x, right, I get 2 times y equals 0, so y is 0. If I put a 0 for y, x is 0. They're both 0, 0. It's both right there. That doesn't help. I need 2 points to make the line. Do you see what I mean?
Mm-hmm.
Yeah?
Yeah.
Okay. Huh. So let's. So what we have to do to graph this is we got to do one of two things. We either even have to come up with another point by just guessing, or we have to change it to y equals mx plus b. One way or the other.
Let's try.
We'll do both. I like this way best. If I can, this one's easy. What plus 2 times what equals 0. So like I could do 4 and negative 2, right? Because 4 plus 2 times negative 2, so like 4, that equals 0. So you just can figure out an answer. What's that?
Okay.
Oh. So yeah, you can just figure out an answer. So 1, 2, 3, 4, and then down 2. 1, 2. It looks like it's right there. I don't know for sure, but that's what it looks like. What do you think?
As long as it's on the same line, right?
Well, where they cross is the answer, and it looks to me like it crosses right there. Now it's a hand-drawn graph. It's not on graph paper. That's the only reason I'm not 100% confident. But I'm pretty sure that
That's the answer.
that's the answer. So I think the answer is negative 2 for y and 1, 2, 3, 4 for x. So I think the answer is this. I think that's the answer where they cross. But it's a graph, so I'm not really sure. And again, if it was like a coordinate plane printed, I'd be more confident. But we have to check it anyway, so let's check it. Now, this has to be true for both, or it's wrong. I know it's true for the second equation because that's how we got the point, right? So we're going to check it for both. So I'm going to check the first one. We'll do it in this color. So 4, 2, right? So 4 for x, right? Plus 2, negative 2 for y. Oh, that doesn't equal 1, does it? Oh, no. That's sad. Oh, so I actually don't even need to check the second one. That's not the answer. That's wrong. That's a sad story. So here's the issue. The issue is actually I have a hand-drawn graph, right? So what we're going to do, this probably would be easy on a regular graph, but sometimes on a graph, if it's a fraction or a decimal, it's just really difficult to see anyway. So this happens sometimes when you try to solve by graphing. So let's do both other methods just to see. So let's do which one do you want to do first, Alexa? Elimination or substitution?
Elimination.
Elimination? So elimination is where you subtract them to get rid of a letter, right? Well, here's the problem with that, and this happens a lot. If you add them together right now, do you see you're going to get 2x plus 3y equals 1, and you didn't get rid of a letter, right? No big deal though, because you see these are both just 1x. So all we got to do is change the sign of one or the other. So I'm just going to go ahead and change the sign of the first one by multiplying everything by -1. Thing is, you have to make sure you do both sides of the equal sign. So the whole thing gets multiplied by -1. So this is going to become -x minus y equals -1. And this one is x plus 2y equals 0. You see? So the second one stayed the same, first one changed. That makes 0, which is what I want. This makes y equals -1. Oh, look, we just counted wrong, I bet. See, we had -2. Yeah. Okay. So -1 for y. -1 for y. So now all I got to do is take that -1 and plug it into either equation and see what I get. So I'm going to plug it into the first one. X plus -1 equals 1. So that's 2, right? Oops. Sorry. You add 1 to both sides, add 1, you get x equals 2. So my answer is 2, -1. 1, 2. Oh yeah, see, my hand-drawn graph is just kind of off. Yeah. So that's the answer, 2, -1. Should we check it just to make sure?
Yeah.
Okay, let's check it. So here's what we're going to do. We're going to check it. We're going to plug, here's our equation, and then we'll check, and then we'll do the same problem with substitution. That way you can see how to do all of them with one example. Okay. Whoa. Why are you throwing stuff? Okay, Ivan, this is the answer we think, right? 2, -1. So I have to check them both, so I'm going to check this one first. 2 plus -1 equals 1. That's true, right? 2 minus 1 is 1. That's good. And then let's check the second one. So it's 2 for x, right? And then plus 2 times y is -1 equals 0. So that's 2. That's -2 right there, right? And that's true also. So this is a solution for both equations. That means it's a solution for the system, because as a system they work together at the same time. So that's the solution for sure. Questions, Alexa?
No.
You sure?
Yeah.
Okay.
Are you gonna post this video?
Probably. Oh, is that a good idea?
It is.
Okay. Let's do the last way.
The last what?
The last way, by substitution. Let's solve this one by substitution. There's a couple ways we can do substitution. Actually, there's a whole bunch of ways. We could solve for x right here and then plug that value in here. Or we could solve for y and plug y in here. Or we could solve them both for x and set them equal to each other. Oh wow. So but here, we're gonna get, man, it's gonna be high quality. You guys are lucky. You're lucky. Right? We're gonna show you. I'm gonna get you guys set up. Let's solve for this x right here. Okay? I just picked one at random. Just pick one of the 4 and solve for that. So I'm going to solve for this x right here. So x plus 2y equals 0, right? So that means x equals -2y. Would you agree? Okay, now I have to plug that into the other equation. So this x right here is the one I'm going to replace. And that's x, right? And this is what x equals, is -2y.
Where did you get -2?
Wait, what?
Where did you get -2?
Oh, I just subtracted 2y from both sides.
Oh.
Do you see now? I'm glad you asked. Seriously, like a lot of times people don't like to ask those kinds of questions because they're like, I feel like that should be obvious is what they feel, right? And they don't want to ask. But then you're like, the whole time you spend on something that you really do understand, you just didn't see it, and then you miss everything else. So I'm glad you asked. They won't even charge you $10 for the answer. Whoa. Why are you throwing stuff at me? Oh, wow. Gravity is working. Right? Man, this is a weird day. It's like the teaching in the Twilight Zone today. Okay. So, Ivan, are you good with how I got all this?
Yeah.
And so you see this is what x equals right here. And so I'm going to take that value of x and plug it into the other one. So I'm going to do that. I'm going to do that right here. Negative 2y, that's what x equals, plus y equals 1. And now I have to solve that whole ugly thing right there. And here's the trick, right? This is the trick. We're taking this x right here, and we're replacing it with what we found x equals from the other
So
equation.
Put in parentheses.
Just so you see it's substituting.
Okay.
Yeah. So then negative 2y plus 1y that's negative y, right? So negative y equals 1, so y equals negative 1. And that's the answer we found earlier anyway, right? Was y equals negative 1. So now all you got to do is take that value for y and plug it into either equation and solve for x. And then you're done. So I'm going to plug that in. I'm going to do the first one because it's easier. So x plus negative 1 equals 1. Add 1 to both sides, right? X equals 2. So my whole entire answer is x equals 2 and y equals negative 1.
Well,
Yep.
it's much easier this way, right?
It depends. Like it kind of depends on what you see. Sometimes one way is easier than another, and sometimes it just depends on what it is that you see, like right then. Like sometimes you recognize something that makes it easy. Okay, you want me to show you another way to do substitution? Otro más way. Like way. Okay, last one. I'll show you how to do this one. Everything okay, Mr. Flowers?
Yeah.
Okay. X plus y equals 1. X plus 2y equals 0. So I'm going to show you how to do substitution one more way. What we're going to do is we're going to solve both of these equations for x. So like this equation, if I solve that for x, I would get x equals 1 minus y. Do you see? Because you would subtract y from both sides, right? Okay. This one, if I solve this one, I get x equals, well, just negative 2y. Because I would subtract 2y. Is that good? You sure? I want to make sure. I know, it's like, it's late. It's dark outside. Right? So, Alexa, are you sure you're okay with this?
Yeah, I do have to keep seeing it.
Right. You gotta I know, right? Okay. So we're almost done. Do you see this is x and that's x? X is the same as itself. And since x equals this and x equals that, these two things are going to be equal. Whoa. Back the truck up, right? Okay, watch. Washa. Mr. Flowers, check this out. This is one of the oldest facts in math. If A equals B and B equals C, right?
Oh.
Whoa. Wait, what?
Then B equals A, I said.
Oh, that's true. That would be true, actually, and that's a fact. But if A equals B and B equals C, then doesn't C equal A?
Yes.
Right, and that's what we're doing here. You see, this equals something, and it also equals something else. Oh, I hate when it gets blurry like that. Oh, I hate my life. See if we can get it fixed. I apologize. Technology makes life great, right?
Sometimes.
Yeah, I know. We need some hold music, like elevator music, while we wait for the camera to stop being stupid. Are you gonna sing? Are you gonna beatbox for us?
He's going for the elevator music.
Yeah.
At the elevator.
In the elevator, right? He's like, oh, the elevator's right around the corner. Okay, there we no.
There's always one missing, right? When
Yeah, I
it's
know.
missing?
I told you that's because I can only imagine 3 of you at a time. Once.
Once.
Okay.
Once. He's been absent once, right?
Oh, the first class.
The first day, yeah. Okay, here we go. Here we go. Finally fixed. Sorry. Okay, so back on track. I apologize. X is the same as itself for sure, right? Like X is equal to X. Like something is equal to itself. Well, it's equal to this, and it's equal to that. So this has to equal that, because they both equal X. So that's what I'm going to write down. I'm going to write that this, which equals X, has to also equal that, because they both equal X. Do you see? X is equal to this, so X equals that, and X is also equal to that, and X is of course equal to itself.
Everything is so confusing.
I know, it's weird, right?
There's a lot of
This and that, and
elimination.
I know, it's like math class or something.
Yeah.
Now we have to solve this for y. We solve this for y. Now the reason I showed you this isn't because it was easier. The reason I showed you this is a lot of times you get problems like this system and they say solve it. And all you really got to do is take these two things and set them equal. But it just it derails things. People see this and they're like, oh, I don't know what to do. But that's
And
what
that's
you
the
do.
answer?
Well, no, that's not the answer. We have to solve for y first, and then we have to plug it in and solve for x. So this y is smaller. I'm going to subtract 1 at the same time. So I'm going to get 1y equals negative 1, which we, of course, already knew was the answer. And then you just plug that in. I'm going to plug it in here. So x equals 2, just like we already knew. And there's the answer. So again, this isn't this method is more complicated, right? Like if we had two equations like this, you probably wouldn't want to do that. But sometimes you see problems that are written like that to begin with. And that's all you got to do. You just got to set this equal to that. Because they're both equal to x, and x equals itself.